Good morning, students. In the last class, we were trying to find the square root of a given number using two different methods. The first method was repetitive subtraction. The second method was prime factorization method. Now, in repetitive subtraction, we were subtracting the consecutive odd numbers in order. Wherever we get 0, how many steps we did, that would be the square root of any given number. In the prime factorization method, we were doing a factor. We were just finding all the factors of that and we were grouping. When we did a group, two groups were taking one number and in the end we were multiplying, and then that would be the square root of a given number. Now we will do a few problems based on that. In exercise 5.3, first exercise is about finding the ones digit, that is the unit digits, which you should be able to do and also explain in the last class. Second one, without any calculation, find the numbers which are surely not a perfect squares. So the numbers which are ending with 2, 3, 7, 8 can never be a perfect square. And third main, find the square roots of 100 and 169 using repetitive subtraction. That means 100 you have to take, start with subtracting 1, 3, 5, 7 and goes on. And in the end you have to get to 0. Fifth main, for each of the following, find the smallest whole number by which it should be multiplied so that you get a perfect square. Now they have given a number, say for example 252. Now the last number you see, right, 252, it is not a perfect square. What their question is, which number should I multiply? They are asking for the least number by which it can be multiplied so that this number will become a perfect square. What we can do here is, let's do a prime factorization method. 252. 2, 126. 2 times 2, 6 are 3 are, and then 3 2s are 1s are 3 7s. Now here, if you write this number 252, it's nothing but 2 into 2 into 3 into 3 into 7. Now this number have a group. This number have a group. 7 does not have a group. So which number we should multiply? We have to multiply 7. The number which does not have a group, we have to multiply that number so that it can be a perfect square. So you will get 252 into 7. See, when they are asking for only the number which we have to multiply, the answer will be till here. If they are asking, multiply the same number to that and get the perfect square, means you have to multiply 7. You get 7 2s are 14, 1, 7 5s are 35, 36, 6, 3 7 2s are 14, 17. So 1764 is the perfect square. So what do we have to do? If they are asking you to check which number to be multiplied. Now first you are doing a prime factorization. After that you are writing it in series and then check which does not have a grouping. That number has to be multiplied. Understood? Now the next one, next main. For each of the following numbers, find the smallest whole number. It should be multiplied. That's the one which we did. For which of the it should be divided. Now in the sixth main, in the fifth main, they are asking for the which number should be multiplied. In the sixth main, they are asking for the which number can be divided. Again, the method is the same thing. Okay, whatever the number they have given, get the prime factorization first. The number is 2925. 2925. to the prime factorization. 2, 9, 5. 4s are 20. 5 5s are 25. 5 8s are 40. 5 5s are 5 1s are 17. 5 3 3s are 9. 3 9s are 3 13s are 13. So write this number 5 into 5 into 3 into 3 into 13. Again check the same thing, group these numbers, and this number does not have a grouping, that means we have to divide. So by dividing 13 we get a perfect square. By dividing we get a perfect square. So the steps for the multiplications and division is same. You just have to do the prime factorization method, and whichever does not have a grouping, that number either has to be multiplied or divided so that you get a perfect square. Now there is a word problem. Find the smallest square number which is divisible by each of the numbers. Find the smallest square number which is divisible by each of the numbers 6, 9, 5. So what do we have to do here is, what exactly they are asking is, you have to get the number which can be later divided by 6, 9 and 15, and that number has to be a perfect square. Now the first step, we have to get the LCM of this particular number. Now the number is 6, 9, okay. Get the LCM of this one, which is 2 3s are 3 as it is, 15 as it is. Now 3 1s are 5s. 1, 1, 1. So LCM is equal to 2 into 3 into 5. LCM. Now in this case, what we have to do is, these are 2 as it is, 15 as it is. 3 1s are 3 3s are 3 5s are. So 3 1s are 5s are. So 5 1 1 1. So LCM is equal to 2 into 3 into 3 into 5. How much is this? 2 3s are 6 3s are 19. Now with this, what do we have to do here is, after we find the LCM, the number which does not have a grouping, you have to add the grouping. Okay? That means this 2 does not have a group, this 5 does not have a group. So by multiplying 2 and 5 to the LCM, which is nothing but 2 into 5 into 90, which gives you 10 into 90. This is the answer for this. Now what was the question? Find the smallest square number which is divisible by 6, 9, 15. If they are asked only the number 90, since they are asking for the square number, we have to add these two and 5, where these two does not have the grouping. Okay? If they are asking only a number, it is 90. Since they are asking for the square of it, these two should have a grouping. This one and this grouping. Since we don't have a grouping, you are multiplying 2 and 5, you get 9. Okay? This is what you have to do. The next method, this is the second method. It is called the prime factorization method. There is one more method. It is called division method. And this division method is very important. I want everyone to concentrate on this and focus. Okay? It is very important for your next classes. In the next class, we will have a finding the square root using division method. Thank you.